Welcome back to the deep dive. We're here again, cutting through the noise and additive manufacturing to bring you the insights that matter. And today, we're diving into something pretty big in the high-end 3D printing world. Bambu Lab just dropped news about their Vortek system. It's for their upcoming H2 series printers, and honestly, it looks like a potential game changer.
Oh, absolutely. This isn't just, another feature. It feels like they're fundamentally rethinking multi-material printing. And for you listening, this tech aims right at the biggest headache in this space. All that wasted plastic. We really need to dig into this because while it's a major technical step forward for the prosumer market, the question is the hefty price tag actually worth it for your needs?
Okay, right. Let's unpack that. So our mission today, figure out how this Vortek thing actually works, how its zero waste promise stacks up against what we have now, and crucially, where this pricey piece of tech fits. Who is it really for? Let's start with the problem itself. Why is multi-material printing such a mess right now?
Yeah, anyone who's tried printing in multiple colors on like a standard single nozzle printer knows the pain. Every single time you switch colors, the machine has to push out all the old stuff, otherwise you get mixed colors, right, bleeding. And this process, this flushing, it creates these huge piles of waste plastic. People call them purge poops. It's wasteful. And it adds so much time to the print.
It's a real physical limitation, and the current systems, well, they handle it, but not very efficiently. Take the Bambu Lab AMS, which is probably the most popular system right now. It works, it's reliable, but the amount of waste, it's pretty shocking sometimes. We've seen solid data, real-world examples where the weight of the purged plastic is basically the same as the finished print, sometimes even more waste than the actual object. That's wild. That must kill your material costs and just drag out print times.
You mentioned some data. How bad can it actually get?
Well, there was one specific case study, a user printing a complex multicolor part. They ended up with 350 grams of waste for a 910-gram object. And that involved, get this, 2,350 color changes.
Wow. 2,350 swaps. That's a lot. And almost 40% waste by weight just from purging.
Exactly. It adds up incredibly fast, both in material cost and just, dealing with the waste.
Right. So how does that compare to the main competitor, the Prusa U3? Doesn't that use a different approach, like a purge tower?
It does. The Prusa U3 generally uses a purge tower, which is that block it prints next to your model. And pretty consistently, reviews and user reports say it's significantly less wasteful than the AMS. It purges a smaller, more controlled amount into that tower. One review I saw mentioned a purge saving of around 300% when comparing it directly to the AMS for similar jobs. So it's definitely better, but it's still waste. You still have that tower you just throw away. Okay, so less waste, but not zero waste. And what does all this tell us about what users actually want? I mean, the community spends so much time tweaking settings, trying custom G-code, anything to reduce that purge volume, right? Trying to save maybe 50, 60%. It really screams that this waste problem is the number1 frustration, the biggest unmet need.
Absolutely. It's the single biggest pain point. And that's precisely what Bambu Lab is aiming to eliminate entirely with Vortek. Okay, so getting into Vortek itself. First, a really important clarification. This system, designed for their new H2 series printers, it's an automatic hotend changer. It's not a full tool changer like, say, the Prusa XL.
Okay, right. So the whole print head, the part with the extruder gears, fans, all that stays put.
Exactly. The heavy stuff doesn't move. The system only swaps the tiny hotend assembly itself, the nozzle, heat block, thermistor part. It seems like a very deliberate choice, probably to keep the moving mass super low and to, work with their existing AMS filament system.
That makes sense. Keep it light, keep it fast. You said the swappable part is tiny, like 10 grams, and it has no wires. How on earth did they power the heater and get the temperature reading back without physical connectors? That feels like the trickiest part, especially with all the vibrations in a 3D printer. Connectors are usually a failure point.
That is the magic trick here.
Yeah.
It's the core innovation. Wireless power and data transfer. By ditching physical connectors, they sidestepped that historical reliability issue with swapping systems. They've basically got two wireless channels working.
Okay. How?
So first, they use inductive heating. Think wireless phone charging, but for the hotend heater. Power jumped across a small gap electromagnetically. No wires needed for power. Second, that little 10-gram hotend has a dedicated microchip on it. This chip reads the temperature from the thermistor, and then it wirelessly transmits that temperature data back to the main printhead board.
Wow. Okay. So wireless power in, wireless data out. That lets them make the swappable part incredibly simple and light. And the printer, the H2C, it has like a docking station for these. How many can it handle?
Yeah, there's a docking slot. The H2C can manage up to 6 of these swappable Vortek hotends. Plus, it keeps one traditional fixed hotend. So that gives you a total of 7 different materials or colors in a single print job.
7 materials, 0 waste purging. And the speed? What's the heat-up time like when it swaps one in?
That's the other headline number. They're advertising just 8 seconds for a newly docked hotend to reach temperature.
8 seconds? Seriously?
Seriously. Now, you have to add the time for the AMS to retract the old filament and feed the new one. But even with that, the best estimates put the total changeover time swap heat filament load at around 15 seconds.
15 seconds total changeover. Okay, let's put that in perspective. The current AMS system, that takes about 95 seconds for a change, right?
Roughly, yeah. And like you said before, maybe 80 of those 95 seconds are just the purging process itself.
So Vortek cuts the changeover by well over a minute. More than 80 seconds shaved off each swap, and it gets rid of the waste. That completely changes the math for multicolor printing, especially for complex models.
It really does. It shifts the economics significantly.
Yeah.
So Vortek nails the waste problem, claims 0 waste, and it's drastically faster. That's the huge win. But, and this is important, it achieves this by leaning heavily on the existing Bambu Lab AMS system for actually feeding the filament.
Right, so they solved waste and speed by essentially building on top of the AMS, not replacing it entirely. Does that mean Vortek inherits the downsides of the AMS, like its fussiness with certain materials,
Yo.
flexible filaments, abrasives, that kind of thing?
That's exactly the trade-off.
Yeah.
Because it relies on the AMS pathway, the long Bowden tubes, the filament buffer,
Yeah.
get stuck with the same limitations. So yeah, things like TPU or highly abrasive filaments like carbon fiber nylon, those are still going to be problematic, just like they are on the current AMS.
Okay, so it's not quite the universal material solution that some might hope for.
No. And if you compare that to a true tool changer, like the Prusa XL, those systems have completely separate extruders, usually direct drive, right on each tool head. That independence gives them much better compatibility with a wider range of materials, including those tricky flexibles and abrasives. It really looks like Bambu Lab made a strategic choice here. They focused laser sharp on fixing the waste issue for common multicolor printing, your PLAs, PETGs, ABS, rather than building an all-encompassing machine for every possible engineering material.
Makes sense. Solve the biggest user complaint first. But what about pure speed? You said Vortek is around 15 seconds. How does that stack up against the Prusa XL's tool change?
Good question. Well, 15 seconds blows the old AMS out of the water. The Prusa XL is still the speed king for the swamp itself. The XL clocks in around 5 seconds for a complete tool change.
5 seconds. It's a significantly faster swap.
Yeah. So if you're doing a print with, say, hundreds and hundreds of changes, the XL is still going to have an edge in overall print time, purely based on that swap speed.
And there's another difference, right? Vortek only swaps the hotend, meaning the nozzle size is tied to that specific material slot?
That's a key functional limitation, yes. With Vortek, if you load PLA in slot 1 with a 0.4 millimeter nozzle, that's always a 0.4 millimeter nozzle for PLA in that job. You don't get the flexibility of a true tool changer, where you could, for instance, mount a big 0.6 millimeter nozzle for fast infill on one tool and a tiny 0.2 millimeter nozzle for super detailed outer walls on another tool and use both in the same print. Vortek can't do that variable nozzle size per print thing. That limits some advanced prototyping workflows.
Okay, so putting it all together, Vortek feels like a very calculated move from Bambu Lab. They're carving out this new higher-end prosumer tier, directly answering the challenge from systems like the Prusa XL and maybe even budget tool changers like the Snapmaker U1. It's like they're saying, look, we've solved waste, the thing you all hate the most.
Exactly. Which brings us to the real bottom line. So what? Who should actually consider buying this, especially given the likely cost? We need to break it down by user type.
Let's start with the heavy users. Print farms, Etsy sellers doing lots of multicolor models.
For them, it's almost certainly a yes, a game changer. The combination of 0 waste, meaning huge material savings, and the drastically reduced print times translates directly to higher throughput and lower operating costs. The high initial price, which is estimated somewhere between $2,500 and $2,900 for the H2C printer, that investment likely pays for itself pretty quickly in a production environment.
Okay, clear win for high-volume producers. What about professional users? Engineers, prototypers, designers who might need more specialized materials sometimes.
That's more of a maybe-e. It really depends on their specific needs. If your work absolutely requires reliable printing with TPU or tough abrasive materials like carbon fiber composites, then a dedicated tool changer like the Prusa XL, despite its own complexities, is probably still the better choice for material versatility. But If your main focus is on multicolor aesthetic prototypes or functional parts using standard materials like PLA, PTG, maybe ABS or ASA, then Vortek looks incredibly compelling because of the efficiency gains.
Makes sense. Material needs are key there. And finally, what about the average hobbyist? Someone just printing for fun, maybe wanting to try a multicolor?
For the casual user or hobbyist, it's probably not the right fit, mainly due to cost. That $2,500 plus price point is just a huge barrier for non-professional use. Even the upgrade kit for the older H2D is looking pricey. Honestly, the existing AMS system, despite the waste, remains the most accessible and cost-effective way for most people to get into multicolor printing right now.
Yeah, that price tag is steep.
Yep.
Speaking of upgrades and availability, when can people even get this? And can current Bambu owners upgrade?
So the full HTC printer with Vortek is scheduled to start shipping late in 2025, so still a ways off. There is an upgrade path announced, but only for users of the previous generation H2D printer. Bambu themselves are warning that it's got complex upgrade, taking multiple hours, definitely not a simple plug-and-play thing, and that kit is estimated to cost somewhere between $600 and $1,000.
Oof. Complex and expensive.
And here's the kicker for most current users. Bambu has explicitly stated there's no upgrade path for the incredibly popular X1C or P1S series printers. The printhead architecture is just too different. So Vortek technology is exclusive to the new H2 platform moving forward.
Wow. So if you've invested heavily in an X1C farm, you're basically stuck with the purge poops unless you buy completely new machines. That's a tough pill to swallow for some.
It is. It defines Vortek clearly as a next-generation feature for their new premium line. Hashtag tag outro. So wrapping this up, Vortek really does set a new standard for efficiency and waste reduction in multicolor printing. It directly tackles that #1 user complaint we talked about, but it's definitely an evolutionary revolution, if that makes sense. It cleverly integrates with and optimizes the existing AMS ecosystem rather than being a complete ground-up redesign for maximum material flexibility. The trade-offs are stark. Incredible speed and zero waste for standard materials, but you sacrifice that broader compatibility with engineering filaments that true tool changers offer.
Right. It's a focused solution. Which leads us to our final thought for you, the listener, to ponder. Given that Vortex shifts the potential points of failure away from filament jams, which are common now, towards new areas, like the mechanical precision of that docking system over thousands of swaps, or the long-term reliability of wireless power and data in a hot, vibrating environment. Which aspect of high-end 3D printing do you think will be the bigger hurdle or limiting factor for innovation over the next 5 years? Is it going to be managing this increasing mechanical complexity, or will it remain the challenge of true multi-material versatility? Something to think about. We'll see you next time on The Deep Dive.